Hello students, myself BISWAJIT CHAKRABORTY, Assistant Professor of SRIST College, Mechanical Department. Today's presentation includes laws of thermodynamics, a very important topic in fundamentals of thermodynamics. Let's get started. Zeroth law. Zeroth law of thermodynamics states that if two systems are separately in thermal equilibrium with a third system, then the two systems will be in thermal equilibrium with each other. Let it be explained. Suppose some firewood is brought in from the cold and an apple pie, one type of food, is removed from hot oven. Both are placed in the same room. With time, the firewood and room reach thermal equilibrium, as will the pie and the room. This means the firewood and the room are at the same temperature. The pie and room are at the same temperature too. Therefore, by the zeroth law, the firewood and pie are at the same temperature, meaning they too are in thermal equilibrium. See if it can be understood again with another word. Let A and B are two systems which are separately in thermal equilibrium with a third system C. This means no heat transfer will take place between systems A and C, and no heat transfer will take place between system B and C. Then no heat transfer will take place between systems A and B. This implies that temperatures of both the systems A and B will be the same. First law of thermodynamics. This law states that whenever there is a cyclic process of a closed system, mechanical work done is directly proportional to the heat transferred. According to the first law of thermodynamics, we can say Q proportional to W, where Q means amount of heat transfer or heat energy, whereas W means work done. And we can also see from general energy equation that is Q is equal to del U plus W, where del U means change in internal energy. Let's understand the first law of thermodynamics with some example. A simple example can be of water stored in a dam. This water has a potential energy due to its height. Now, when this water falls down, this potential energy is converted into kinetic energy. This kinetic energy then rotates the turbines and electricity is produced. So the potential energy gets converted to kinetic energy, which in turn helps us to produce electricity, and thereby the total energy remains constant. Limitations of first law. This law states only mutual convertibility of heat flow but does not specify the direction of heat flow. That is, it does not specify whether heat will flow from hot body to cold body or from cold to hot body. While mechanical work can be fully converted into heat energy cannot be fully converted into mechanical energy. Hence, the conception of mutual convertibility of heat and a mechanical work is not fully true. If I want to give you an excellent example, then I have say the following example for showing limitation of first law. When we rub palms of our two hands, heat is generated. The same heat cannot be used to reciprocate the palms of our two hands. To read about the second law of thermodynamics, we need to know about two statements. One, Kelvin Planck statement. Two, Clausius statement. Kelvin Planck statement. It is impossible to construct a heat engine working on cyclic process which can convert all the heat supplied to it into equivalent amount of mechanical work. First of all, we consider supplies heat is a source, absorbs heat is a sink. Let Q is equal to heat supplied to a heat engine from a high temperature heat reservoir called source in any time T. W is equal to work done by the heat engine in heat unit in the same time T. According to the Kelvin Planck statement, W is less than of Q. Then according to the law of conservation of energy, heat rejected to the low temperature heat reservoir called sink is equal to Q minus W. Clausius statement. It is impossible for a self-acting machine unaided by an external agency to transfer heat from a body at lower temperature to a body at higher temperature. That is, from sink to the source. Heat can flow from a high temperature heat reservoir called source to a low temperature heat reservoir called sink. But if heat is to be transferred from the sink to the source, help of external agency is essential. This external agency is nothing but a heat pump. Thank you all.